So in our last video, we talked about how to complete the square when a was equal to 1. In other words, when we had just a plain old x squared in our quadratic. In this video, we're going to address questions where there's a number besides 1 in front of our x squared. So if you look at this example down here, we have a 2x squared as opposed to just a typical 1 for a. Now, there's actually two different ways of doing this process. You may learn a different way in a future class, but I've kind of decided this is the way that I like doing these best. So just realize there is another method out there. But the way that I like to think about these problems here, it actually makes things considerably more challenging when there's a number in front here. It doesn't work as cleanly with completing the square. So my thought process is I just want to make it a regular x squared so I can use the rules that I'm already used to. So what that essentially means is that I'm going to take my equation and divide everything, both sides of the equation, by 2. 2 being in front of here, because I want to kill that 2 off so I have just an x squared, because then I know I can use my old rules. So when I divide by 2, essentially you have to divide each term here by 2. I end up with x squared plus 8x minus 20. And on this side, 0 divided by 2 is still just 0. So I took my equation, I divided everything by my number out front, my a right here, because then I got a nice problem with just x squared. Once you do that, you treat it like the problems in the last video. So I add my 20 to get out of here. I put my box on both sides, and I do all that math that we've been practicing on completing the square. So I end up with 20 plus box over here. Half of 8 is going to be a 4, and 4 squared is 16. So I need to add 16 to both sides. Kind of running out of room here, so I'll kind of switch over to the side here. So this left side is going to factor into x plus 4 squared. And on this side, the right side, I end up with a 36. So I took my problem and I rewrote it up here. Well, at this point, I can do my square root method. I get x plus 4 equals plus or minus. And on this one, square root of 36 is just 6. I do a minus 4 on both sides. I get x equals negative 4 plus or minus 6. And as you guys recall, when you have a situation where they're nice answers, just go ahead and do the math here. I'm going to end up with x equals 2 and x equals negative 10 on this problem. As a side note, when you get really nice clean answers like these ones right here, x equals 2 and x equals negative 10, that's a signal that this thing actually factors when we do completing the square. So like this guy right here, if I did magic numbers on, this guy actually must factor, the fact that we got nice integer solutions there. But that's kind of a side note. Completing the square worked out just fine for us there. Let's go ahead and try out 2 more examples in this video. So on my next problem here, again, this negative 5 out front is a problem for us. It makes the problem different, and it's really kind of difficult to complete the square when you have that number there. So I say just divide everything by negative 5 to get rid of it and just deal with a normal problem. When I do that, I get x squared minus 14x, and that negative 495 divided by negative 5 is going to be a plus 99 equals 0. And again, all we're left with is a regular quadratic with a equal to 1, and you just do the typical process. So the more examples of these you guys practice, the better you should be getting at them. And at this point on this one, the number that's going to end up going in our box is going to be a positive 49. So we end up with x minus 7 squared on this side, quantity squared. And on this side over here, we end up with a negative 50. So we do our square root method. We have square root of a negative, so we're going to be dealing with an imaginary solution. We get x minus 7 equals, it'll be plus or minus 5i root 2. If you simplify the square root of 50, you'll get 5 root 2, so it'll be 5i root 2 on that one. And if you add your 7 to both sides, you'll get x equals 7 plus or minus 5i root 2. And our final problem in this video, again, all we're going to do is divide by a, whole problem. So I divide everything by a 3 here. I get x squared minus 4x. Now on this one, it's a little unfortunate. My number didn't divide cleanly, my c didn't divide cleanly like in the previous examples. It's okay, you just deal with the fraction. We'll get a 7 over 3 here. And on this side, 0 over 3 is still just 0. So the process still works the same. Don't let the fraction bother you. So we get x squared minus 4x box equals, it'll be negative 7 over 3 plus box. And half of negative 4 is negative 2. Negative 2 squared is a 4. We need to add 4 to both sides here. So this side isn't so bad. It just factors into x minus 2 quantity squared. But this side over here is not as nice. We have to do negative 7 over 3 plus 4, which, again, by this point, fractions shouldn't be bothering you guys too much. You're just going to multiply top and bottom by 3 on this. Negative 7 over 3 plus, it'll be 12 over 3, is going to get me a positive 5 over 3 here. So when I go to do my square root method, I'm going to have kind of an ugly looking answer here. It'll be x minus 2 equals plus or minus the square root of 5/3, which doesn't really simplify very cleanly, so I'm just going to leave it as is. Final answer on this problem will be x equals 2 plus or minus square root 5/3. You could get decimal answers, but it's not necessary for this. You can just leave your answer like that.